Hello everyone. In today's class, let us start discussion about the concept equilibrium. So equilibrium we need to discuss from the Newton's laws of motion. So before discussion equilibrium, we need to know about some basic concepts like a free body diagram. Okay. So what is FBD and what is its necessity to learn first of all before knowing the equilibrium, right? So let us take the concept first here. Diagrammatic representation of a body which is isolated from its surroundings, showing all the external forces acting on it, which means you just understand when object is placed on the table, okay, like this situation, and we need to apply coordinate system along x-axis and along y-axis, and what are the forces acting on it, and we assume it is as isolated system from the surroundings. So to represent all the forces acting on it with the help of arrow marks, so that is especially express that free body diagram. Okay, suppose here this is one object, F1 is acting downward, F2 is acting left side, and F3 is acting on the right side. Suppose an object is exerted by these three forces, we need to represent with them with arrow marks. So this diagram, this picture is called free body diagram. Okay, but whenever it is placed on the table, so what are the forces acting on it, we need to draw. So here how to draw the FBD? First point, what is that? Identify the system. What kind of system it is, we need to know about first of all. Second one, draw all the external forces acting on the system. Here we can consider, suppose its mass is m, so we can take its mass is m, okay na? Now it is a block B, so block B we are taking, and its mass is m we are taking, and draw all the external forces acting on the system, which explains what are the forces acting on it, we need to draw them, okay na? Next, third one, choose axis and resolve the forces along them. Means some cases forces we need to resolve into components, rectangular components along x-axis and y-axis to solve the question, okay na? So generally we need to represent here first of all in which direction forces are going to be acting. So first, suppose the same object is kept on the table, so its weight force acting vertically downward, okay. So that's what we represent with arrow mark, downward arrow mark with mg. Next, through the same center, actually it is acting through the center of mass. So what is the center of mass? Means total mass is assumed to be concentrated one point for the object, that is called center of mass, okay. Through this center of mass, weight force act downward. Weight force means actually force of attraction of gravity on the body, that is acting through center of mass downward, and being it is present on the table, so table will be exert equal and opposite force opposite to the weight force, that is upward force we call reaction force, otherwise normal force, okay na? And here this normal force magnitude is exactly equal to mg. Why? Because if F net equal to 0, acceleration is also 0. We get two conditions. What are they? First one is it move with constant velocity and it is at rest. Here object is at rest. So object is at rest means acceleration ultimately 0. Then F net acting on the body also 0. So that's what here from this situation n equals to mg we can get. So this is secondary. In solving the questions we apply, but what is the major thing we are discussing is a free body diagram. How to draw the forces acting on the body. This is one situation we can take. Okay na? In second example we can see, this is a wedge or inclined plane we should call. What we call wedge or inclined plane. Okay na? So a block of mass kept on the wedge, whose mass is m, suppose, right? So now its weight is always acts vertically downward. you just understand here, its weight is always acts vertically downward. Weight force acting vertically downward through the center of mass. Now, we need to resolve this force along the inclined plane and perpendicular to inclined plane. That is required conditions. It depends on the question. But it is actually in which direction force is acting we have derived or we have just indicated. Next to second point, perpendicular to contact. You just remember beta. So, normal reaction or reaction force always perpendicular to surface which is in contact with. ओके ना. सो जो भी सरफेस रहता है उसको परपेंडिकुलर में रहना चाहिए. सो यहाँ पे नॉर्मल फोर्स वैसा ड्रा कर सकते हैं, राइट. सो हियर फर्स्ट वी नीड टू अंडरस्टैंड this is the direction of reaction force. We can indicate sometime it will be given by N, sometimes it will be indicated by R. Both letters we can use to represent. Okay na. Now components we need to take like perpendicular direction to the inclined plane and here parallel direction to the inclined plane. So this become theta. So then mg value along this one becomes mg cos theta and here it becomes mg sin theta. So thus we get some forces acting on the body which is placed on inclined plane like this manner. Okay. So this is also shows the free body diagram for the object, right. So this is how we can able to draw the forces acting on a body whether it is at rest or moving. And next case we will see. A block of mass 5 kg is kept on a smooth surface. So this is the smooth surface actually they are called given in the question. Okay na. So whose mass is 5 kg generally. Next a force of 25 Newton is applied as shown. So this is the external force which is exerting on the body in right side as shown by the arrow mark. Okay na. Then find the acceleration of the block. Now we need to take the net force. It is very simple question, but to understanding purpose we have taken it is as a free body diagram, how to explain and how to use in solving of such a questions. Just we are starting with a simple question. Okay. So what are the forces are acting on the body? First we need to take out. So there is a force right side acting whose magnitude equal to 25 newtons and one is it is on the table. So on the table is there or just we can hold or just it is falling everywhere. Its weight force acting vertically downward. That is what 5G. It is actually we written in the form of mg through the center of mass only acts and vertically upward. This is a normal force. Okay na. Otherwise normal due to ground surface they have given here. Okay. Reaction force. Now the block will has a tendency to move forward. Okay. It won't move vertically upward or downward. So that's what whenever it is not moving upward or downward along y-axis here you can just understand along y-axis. The sum of net force acting along y-axis is 0. Why? Because acceleration 0, so force also 0. Okay. So we can take whatever the force acting, sum of force acting in y direction is 0 and what is the force in vertically upward? N minus mg. N minus mg equal to 0. Then we can take N equal to mg and simply we can take this is net force 0 na. So net force 0 means acceleration in y direction 0. In some cases, if force is applied inclined direction, then there is a chance we need to take one force component in y direction, one force component in x direction. Okay na? So then acceleration in y direction we can have, right? So here in this case acceleration in y direction is 0. Now let us observe along x-axis. Since force acting in x-axis, there is a tendency to move in x-axis only, and with what acceleration it can move actually, let us see. Along x-axis. So what is the net force? Sum of force along x-axis 25 newtons. Okay na? No other force acting other than 25 newton. So from the second law of motion F equal to ma. So we can know that mass is 5 kg. So simply we can write down that is Fx equals to 25 Newton, and here Ma equals to 25. This is 5A equal to 25. This is 5 5s. So acceleration along x-axis will be 5 meter per second square. Okay, so in y direction 0, in x-axis 5 meter per second square, and net acceleration in some cases they will ask acceleration net equals to ax I cap, ay j cap, that is 5 I cap plus 0 j cap, finally 5 I cap meter per second square, and its total magnitude of acceleration also 5 meter per second square. Okay na? So this is the way we can solve for the question based on FBD. Next case, two blocks in contact where we can draw FBD. So here A block placed on the B and B is placed on the table. Okay, and what are the forces acting on the block B? Let us observe first. Okay, so this is an isolated system we can consider. So draw the external forces. Second condition, what are the conditions to what are the steps to follow the free body diagram we have learned in the previous slide. So with the help of that, next to draw the external forces. So what are the forces going to be act? Let us see. This is block. Okay, so block B. On the block B, downward force will be what? Mg. So this is no problem, just we discussed. Next, one more force will act upward, that is what? Normal due to ground. Okay, this is no problem. Then where does it come actually? So NBA, it come extra here. Why it should come extra means you should understand, on the block B, A block is placed. Then it will exert some contact force here. We will we have discussed already some forces types. Okay na? So here the A block exerts some normal or reaction force on the block B, and here the same force will exert by the B on A also. I will show on the A block also here. Okay, so now A exerts some force on the B, that is I am just taking in the slide as NBA. This is normal force by block A on B. Okay, so this is the additional normal force because there is a block placed on the B. Otherwise, we don't have this kind of value. Only these two forces we can write down. If it is represented as a point size manner, the same kind of answer will come, and just we can take x-axis and y-axis, we can resolve the components. Otherwise, in any direction you can get. Okay na? So this is the way we can get the free body diagram for the case of block B. Let us see for the case of block A. This is block A. Okay, so for block A, downward will be mg. Okay, so next normal force exerted by the block B is it will be acting on vertically upward direction. So this is okay na? So here normal force by the block B on A, this value will be same on both the blocks, but directions are opposite. Okay na? So this is the point we can get for the case of block A, right? Let us move on to next slide. Here is our original concept, equilibrium. Okay na? So what is equilibrium? Generally we need to define. So let us start with the definition. When the net force on the system is 0, means there is no net force acting on the system. Okay na? The object is said to be, or the system is said to be in the state of equilibrium. Okay na? So here the forces are being acting on the body, but the net force whatever they are acting on the body is sum equal to 0. So then that object is said to be in the equilibrium. So here just you can consider F external acting on the system, that is sum of F external on the system will be 0, then f of x means sigma summation of fx equal to 0, which means along x-axis also 0, along y-axis also 0, along z-axis also 0. Generally, this concept we know, or we just get the part for translatory equilibrium. Okay, beta. So, translatory equilibrium means, suppose one example we will consider an object. This is, it is being pulled by some force continuously, one person. Okay, na? F1 force, right? And at the same instant, one more person is pulling the same object with F2 force. Now, object is at rest still. Object is at rest means acceleration of the block will be 0. So, acceleration 0 means then definitely F net acting on the body will be 0. So, here F net acting on the body, just I am taken only exerted forces along x-axis, so I can write Fx equal to 0. Okay. So, then what are the forces we have? F1 minus F2 equal to 0, because direction, with depending on direction I took here minus. Okay. So, then what we can take? F1 equals to F2, that is secondary, but net force acting on the system is 0, na? We are getting. So, that's what it is in equilibrium. So, which is not moving either direction, or it is not moving in x-axis positive direction, or it is not moving in x-axis negative direction. So, then it is said to be in equilibrium. In the same scenario, more forces are also acting. That is one, weight downward. Next, reaction force upward. Then the block not moving in y direction also. Then what happened? Fy sigma equals to 0. Then this condition satisfied. Okay, na? And it is 2 dimensions, so we can get Fz. If 3-dimensional case, if you can understand, then there is a chance to get Fz also 0. Okay, na? So that is here n minus mg is equal to 0, where it explains n equals to mg. Means it is not moving along x-axis, not moving along y-axis, and no force along z-axis, so it will not move along z-axis also. Okay. So, here one small example is given. Okay, na? Whenever just a block of mass is tied with the string, suppose, and it is in the oscillatory condition, then what is the tension force acting on the body, and it is resolved into components. So, we can take this situation. Okay, na? So, its original diagram must be looks like here, this one. Here it is suspension point, here it is wall. Okay, na? And it is make some angle. Then wall exert normal force on the block right side, and here it is exerting tension force in upward. Okay, na? So, tension component here T cos 30 because theta 30. So, T sin 30 left side. So, it is not moving along x-axis. Also, it is not moving along y-axis. Then it is said to be in equilibrium. Okay, na? So, here tension force, weight, normal force. 3 forces are acting on the body. But these 3 forces sum equal to 0 definitely. Then only we can say this body is said to be in equilibrium. Okay, na? So, its original diagram will be looks like here. Let me explain the diagram here. Like this it will be. Okay, na? So, then we can just take the angle here. Like this, right? So, this is the center of mass, and right side direction normal by the wall, and downward mg, and here if it is any angle theta, this point of contact. So, away from point of contact only tension force act. So, that is what we can take. Here it is theta becomes, so T cos theta, and left side it becomes T sin theta. Okay. So this is the way we can get the components of forces acting on the body, and T sin theta must be equal to NW, which is normal by wall, and T cos theta equal to mg. So x axis force equal to 0, y axis force equal to 0, then it is said to be in equilibrium. Okay. So this is one more example we just seen. Next, what are the major conditions? More conditions are required. And what explains for a rotational equilibrium and translatory equilibrium. Just we have gone one step ahead here. Okay, na? Actually, we don't discuss rotational equilibrium in this lesson. You will discuss or you will get the concept related to this one in what rotational motion. Okay, na? Because you don't know what is torque at this time. Okay, so don't get confused here. Just for the sake of equilibrium, just I am covering this part. Okay, na? So now, the necessary and sufficient condition for the translational equilibrium. Translational equilibrium means it is not moving along the line. Okay, it is also compelled by forces, but net forces acting on the body 0. Okay, na? So that's what the net force acting on the body 0, which means already we have seen in the last slide fx0, fy0, fz0. Then the body is said to be in translational equilibrium. Next, for rotational equilibrium means the object should not rotate. Okay, na? Like if it is try to rotating, torque will be help to rotate actually. Okay, na? So torque means generally force into perpendicular distance, where torque equals to force into perpendicular distance. Okay, and you will get to know more details in this regarding torque in the rotational motion lesson, and don't worry about this in this part. Okay, so now same case, rotational equilibrium means net torque acting on the body 0, then object will not be rotated, it will be in a rotational equilibrium. So torque x equal to 0, torque y equal to 0, torque z equal to 0. And more concept we can develop for translational equilibrium. Here you can see, just I have said in the words in the last slide, if F net acting on the body is 0, F equals to what according to second law? F equals to ma. That is F equal to 0, that is ma equal to 0. So that is acceleration can be written as dv by dt. Okay, acceleration dv by dt equal to 0. But here mass does not become equal to 0 because mass will be present something, okay, na, for the object. So it won't become 0 according to conservation of mass. So now dv by dt equal to 0. Then dv by dt equal to 0 means acceleration equal to 0. Condition is acceleration 0 means we get two conditions, velocity constant and next rest particle. So velocity is constant or 0. Velocity 0 means particle is at rest. Velocity constant means acceleration 0. Okay, na? In both the case acceleration 0, but it is said to be in what? Equilibrium. But you need to remember this point more clearly. Okay, na? So you can solve reversely. Actually, when you solve reverse, you can get the concept actually. So here acceleration we got 0, na? So how to get reverse we can do. If I supposed to be take velocity constant, if I do differentiation for the velocity with respect to time, because velocity differentiation with respect to time gives you acceleration. So constant differentiation gives you 0. Then acceleration 0, which explains F0. So this is a reverse way of the understanding the same concept here. Okay. So that is velocity might be 0 or constant when a particle is in equilibrium. So let us know more points here. Here it is one of the important theorem statement and theorem here. Okay. That is Lami's theorem, which we use generally to solve the equilibrium based questions. Here it is the one particle actually. Okay. This is one particle. Here it is one particle, you just consider. Okay, na? On which the force F1 acting right side and F2 acting at some angle, F3 acting at some different angle. But the angle between F1 and F2 gamma and F2 and F3 alpha, F1 and F3 beta. So this situation we got. In such a situation, sine rule or Lami's theorem we can say, that is f1 by opposite sine angle. So I will explain clearly in the figure. You can just see. This is the scenario. Here it is the object and it is being compelled by some forces. Okay. So suppose to be take this is f1 and this is f2, this is f3. So here I have written already sine alpha. So according to that only I am choosing the angles also. This is beta and this is gamma. And these may be equal, may not be equal. So that's what the diagram is completely different patternly given. So it may be equal, may not be equal. That depends on what f1, f2, f3 magnitudes definitely. But how to apply Lamy's theorem point here? f1 divided by opposite forces angle sine ratio. Opposite forces what? Remaining forces what? f2 and f3. And for f1 opposite means remaining forces. f1 after f1 when you are writing here, its ratio with sine angle you are taking, that angle must be remaining two forces. The angle between remaining two forces we need to consider. Okay na? So that is sine alpha. Next when you are writing for f2, so f2 remaining forces are what? f1 and f3. Then angle between f1 and f3 is beta. Then it's a sine ratio. Next to f3 here and remaining forces f1 and f2. And what is the angle between them? Gamma. And it's a sine ratio. Here sine ratio. This ratio is always equal. So we use this ratio to be to solve the numericals based on this Lamy's theorem point. Okay na? And mostly we will solve by component resolving only, and whenever it is required we can use Lamy's theorem based questions also. Okay na? Means Lamy's theorem also we can use to solve the questions, right? Let us move on to next part. Here it is the situation showing in the diagram. Okay, the bob of a simple pendulum is held at rest by applying a horizontal force. This is horizontal force applying on the bob as shown in the figure. If body is in equilibrium, in this position if it is in equilibrium, okay, so what forces are acting on it we need to draw first, then secondary, and it is in equilibrium, so fx equal to 0, fy equal to 0. Okay, so then let us see here, if it is making an angle theta with vertical, this is point of contact, so away from point of contact tension is going to act, and then it is a transverse for the parallel lines. You can see this become theta, so t can be taken along this one is t cos theta, along this one is t sin theta, and downward force here, downward force, what is the downward force? mg, if mass of the bob is m, and right side force, applied force here. Actually a person is applying force right side horizontally to make it in equilibrium, which means a person is just pulling right side and it is making an equilibrium like this situation. Okay, in that case it is in equilibrium na. So now along x-axis forces equal to 0. Okay, summation. At the same time along y-axis also summation of forces equal to 0. Along x-axis net force 0 means left side force equal to right side force, that is t sin theta equal to f. So we can take that is t sin theta equal to f. At the same time vertically upward force equal to vertically downward force, because fy also 0. So t cos theta equal to mg. Okay na? So now we can take this is equation 1 and this is equation number 2. Let me derive 1 upon 2. So first equation we have t sin theta, and second equation we have t cos theta, that is f upon mg. So t cancel, sin by cos, it is equal to tan theta, that is f upon mg. So if f is given, then we can find out theta, or theta is given, we can estimate f. Okay. In second case, 1 square plus 2 square if I do, okay na, left side what? T sin square theta plus second equation left side t cos theta, means square only I am doing and adding. Right side f square plus mg whole square. So t square we take common, sin square theta plus cos square theta. It is an identity for trigonometry. So its value equal to 1. Then we get t square equal to f square plus mg whole square. Then t equal to this answer. Okay, root over f square plus mg whole square equal to t. So this is the way we can find out tension in this case. Okay, na? So next slide, let us see. Here it is one small question based on the equilibrium part only. Okay, a mass of 3 kg is suspended by a rope of length 2 meters. So here you can see this is 1 meter and this is 1 meter. Total length will be 2 meters. Okay, na? So from the ceiling, a force of 40 Newton in the horizontal direction is applied at midpoint P. This is midpoint P and it is being applied a horizontal force 40 Newton right side of the rope as shown. What is the angle the rope makes with the vertical? Means with which angle it will be in the equilibrium position with vertical, they are asking. And the tension in the part of the string attached to the ceiling. In this string, how much tension will be? They are asking. Okay, so let us go with the concept here. First, this is the point where they have applied force. But here, what is the mass of block here? 3 kg beta. So 3 kg means a downward force acting 3 into g on the basis of EMG. Okay, na? So let us take here this force. This is point of contact and away from point of contact one tension is going to act. Let us suppose in this portion T2 you can take. Thus their rope is same, na? Means the point of application is here. Below the point of application single rope is here. Actually totally single rope, but the point of application above some part, below some part. So below part it will be maintain same tension. Okay, so that is for this point away from the point of contact T2 only force act. Okay, next here right side 40 Newtons acts and with respect to this point away from this point T1 force act. So with vertical they took here theta. So T component will be along this one T1 cos theta and along this one T1 sin theta. Now this point is in equilibrium. You can apply Lami's theorem and you can apply components method equating. So both the way we can solve this question. Okay, na? So now here first of all resolve the tension T1 into two mutual perpendicular components. So whatever we did T1 cos theta, T1 sin theta. So let us see first of all. So T1 cos theta is a vertically upward and vertically downward force is what here? T2. Okay, T1 cos theta equal to T2 generally. So let me write here T1 cos theta equal to T2. But T2 is equal to how much? 3g. That is 30 Newtons. Okay. So when T2 equal to 30 Newtons, then you are substituting here T2 value, then T1 cos theta equal to how much? 30. So that is only we have written here. So you can observe T1 cos theta is equal to W is equal to T2 also from this case. Okay. Next T1 sin theta left side force and right side force will be 40 Newtons. So Fx is also 0. So we get T1 sin theta equal to 40 Newtons. And we can let's say this equation 1 and say this equation 2 and doing second by first, which means sin by cos. T1 cancel. So we get a tan theta equal to 40 by 30, which is 4 by 3. Okay, na? So that explains 4 by 3 angle. How much beta? Tan theta equal to 4 by 3 means theta equal to 53 degrees. Okay. So next squaring and adding the both equations. Just now we seen in the last case how we get tension value. Tension square equal to W square plus F square, because whatever the values it is equal to. Okay na? So then on equating squaring and summing both the equations, we get this function. W means how much we got, 30 square, and F means 40 square. 30 square 900, 40 square 1600, total 2500. So that equals to 50. So whatever the part of tension in this wire is, we get 50 newtons. Okay na? So that is what. And what is the tension in this part? 30 newtons. That's it. Okay. So this is the way we can solve the question, by solving or resolving components into perpendicular directions. Next question. M is suspended by a weightless string. The horizontal force required to hold the mass at 60 degrees with the vertical is. Okay. So they are asking what is the force required. Okay na? So suppose I am applying some force on this case F, and theta equals to, they have given 60 degrees. Okay. This is also 60. Just now we have seen this is away from point of contact, tension X, and tension component along this one T cos theta, along this one T sin theta. So it is in equilibrium. They will say that it is in equilibrium. Okay na? Weightless string, horizontal force required to hold the mass at 60 degrees. Hold the mass at 60 degrees means it should be present at the same position. So it will be in equilibrium, because force is acting and it is at rest. So then only we can call it is in equilibrium. So upward force equal to downward, left side force equal to right side. So Fx 0, Fy 0. Then T sin theta equal to F, and T cos theta also equal to mg. So from this equation, that is sigma summation of f of x, or summation of fx equal to 0. So f equal to T sin theta, sum of forces in y direction equal to 0, that is T cos theta equal to mg. Okay. So then we can take first equation, second equation, and first and second Tt gets cancelled, sin by cos, tan theta we get. So f by mg. F equals to mg tan theta, but theta is given 60 degrees. So tan 60 equal to how much? Root 3. Okay na? So this is what the force required to hold the mass at an angle 60 degrees with vertical. Okay. So next, here is one question. A cylinder of weight W. Okay. So its weight is W. It is just placed as shown in this diagram. So its weight acting downward, resting on two inclined planes, forming V groove. Here it is V groove as shown in the figure. Ignore friction everywhere. We don't learn friction in this part. We will learn friction in the friction lesson after NLM. Okay na? So now all the surfaces are smooth only we consider. Here 60 degrees, here 60 degrees. But here total angle how much? 180. 180 minus 120, here also 60 degrees. Okay na? Now if you make a bisector, this become 30 and this become also 30. Okay, 30 degrees with bisector, right? Next, draw its free body diagram on the sphere. Okay, actually cylinder only that is. So calculate normal reactions between the cylinder and two inclined walls. So they are asking to find normal reactions also. Okay na? That is, here we can take let us see. This is free body diagram for the respected case. So vertically downward W will act. Okay na? So next you can see here diagram. So it is an inclined plane and it is a W. So just now I told you this angle how much? Bisector angle 30 degrees. So we can take this angle is 30 degrees. Okay. So this is center of mass of the cylinder, right? At this point I am taking. Now this is horizontal direction, and in this way I told you normal force. In which direction normal force act? Always perpendicular to point of contact. You can see this is perpendicular to point of contact. Okay na? So this is 30, this is 60, then this become how much? 30 degrees. What is the point? So here it is written, you can see this normal n exerted by first wedge, okay, and its component along x-axis, how much here it is taken? N cos 30. How like? You can see n here, n cos 30, and vertically upward, okay, vertically upward, n component horizontal direction, n cos 30, and here it becomes n sin 30, like that. The same way here components will take in opposite side. So n cos 30, n sin 30. Let us see, the cylinder is in rest, means is at rest. So equilibrium, total downward force equal to upward, means y direction force sum equal to 0, x direction force is sum equal to 0. So now you can check here, first point, F along x-axis is 0, okay na? F along x-axis 0 means, you can check, this is if you can take n1 and right side if you take n2, then what we can write? N1 cos 30 right side force, and this is how much? N2 cos 30. N2 cos 30, cos 30, cos 30 cancel, so N1 equals to N2. And if you just have a ambiguity here, sir, first wedge exert N1 and second wedge exert N2, then also we can show that N1 equal to N2. So there is no problem. Directly if you take N and N also. Otherwise, N1, N2 only you can take, because you just begin to start the question. Definitely you need to take N1 and N2. Then N1 cos 30, N2 cos 30 equals, so N1 equal to N2. So now onwards we can take N1 equal to N2 na. We have given a proof, okay. So now y direction net force equal to 0. Then total upward force means what? One component here n sin 30 and here also n sin 30, means total 2n sin 30 upward. Then total downward force how much beta? W, okay. Sin 30 how much? 1 by 2 and 2 cancel, n equal to W. You can check, okay. So here they have taken 2n cos 60, okay na. So as this angle, based on this angle they take here, okay, no problem. Here cos 60 also 1 by 2 only, sin 30 also 1 by 2, no problem here. The answer will be same, right? You can check. This is sin 30 also, right? So equals to W. Then we can take W equals to 2n into 1 by 2. 2 cancel out. Then normal force equal to W will come. So whatever we just shown here, this is vertically upward force, vertically downward force. 2n sin 30 equals to W. 2n 1 by 2 W equal to 2 cancel and n equal to W will come. That is total normal force exerted by one wedge equal to W and second one also equal to W. This is the way we can solve the question in this manner, and that is free body diagram, and calculate the normal reaction between cylinder and wall is n equal to W, right? Let us move on to next part. A 50 kg homogeneous smooth sphere, okay. So here it is, they have given, it is a 50 kg mass, okay. This is a 50 kg mass and vertically downward act to 50 G weight force. Rest on inclined plane 30 degrees. So you can take this angle will be 30 degrees, right? Incline A and bears against the smooth vertical wall. Calculate the contact forces at A and B. So here normal force, they are asking to find, okay na. Once again I am recalling the statement, normal force is always perpendicular to point of contact. Let us take here, this is a normal A, because wedge exert normal force in this direction, and here wall, So this point of contact to perpendicular direction in this one, NB. Okay. So now you can check here first of all, if I take its component along this one, okay. So this is 30, this is 30, okay na. So this angle 30 and this angle also 30. Then this angle become 60, okay. So now this angle become 30. You can take by 30 degrees or you can take by 60 once again. Let me draw clearly here. This is here normal force acts along this direction. This is normal A, and we can take along x axis and along y axis, right. So this is given 30 degrees. So this is also become 30 because these two parallel lines, it is transverse. So now this is 90 degrees. So whenever it become 30, this become 60, okay. So now NA cos 60 and here NA sin 60. So we got components, okay na. And NB we have only along x axis because y component will be 0. So what are the forces along x axis and y axis we need to get. So here also same kind of explanation taken, here N1 taken and N2 by the wedge. So N2 vertical component cos 30, horizontal component sin 30. I have taken in terms of 60 degrees, sir. So that's what values will be might change, okay na. And if they if we take this is 60, no, this is 30 degrees. Whenever it is 30, NA will become NA cos 30. Cos 30 sin 60 same only na. So here also same one, okay. So now along x axis net force will be 0 because it is in equilibrium. So right side force how much? NA cos 60 and left side force NB, okay. So you can see okay, first vertical direction we will check out, okay na. Vertical direction, downward force how much? 50 G means 500 newtons. Upward force means this much, you can see NA sin 60, okay na. So now we can take the concept here, NA sin 60 equal to 500. You can check NA means they have taken N2 beta. So here horizontal direction sorry, vertical direction Fy equal to 0, N2 we have taken NA, wedge A, NA cos 30 we got sin 60, cos 30 root 3 by 2, sin 60 also root 3 by 2 equal to 500. This is root 3 by 2, 2 will come here, 500 multiplies 1000 will come, 1000 by root 3 we get N2 or NA, both we can. I have explained with NA and it was given in the diagram N2, okay na. So both the way will be same answer. Next, horizontal direction, along horizontal, force along horizontal direction 0 only because again it is in equilibrium. So right side force equal to left side, right side force NA cos 60, left side force NB. So you can check NB means NB means NB only, N1 here, okay na. Wall exert force N1, this is N1, okay, equal to N2 sin 30, here this is N2 sin 30 and we have got NA cos 60, NA cos 60 means sin 30, okay. So NA cos 60 means sin 30. So we get a N1 value, we need to get N1 value before getting N2 value how much we got? 1000 by root 3, 1000 by root 3 into 1 by 2 and just doing cancellation 2 ones here 2 500s, 500 by root 3. Our final answer for normal force by the what N1, N1 is taken by what? Wall, okay. So our concept NB, NB equal to wall, okay. If you have any confuse, I will take same values also, no problem, okay. It is given N1 and it is given N2. Here N2 cos 60 will come, okay na. I just take 60 degrees with horizontal, the same concept we can solve with vertical direction 30 degrees. For anybody they can feel, sir, we get confused from here to here, okay. Let me explain this concept with the taking of same angles. See what they have taken N2. This is N2. Then this angle is how much? 30 degrees. N value along this one how much? Cos 30. This is N2 sin 30. Okay. Now there is no doubt here in this case. Just we get the same answer. N2 sin 30 x-axis, first y-axis. N2 cos 30 upward, downward 500. So you can see N2 cos 30 upward, 500 downward. Cos 30 we get root 3 by 2, so we can get N2. Got clear? Next, x-axis. N2 sin 30 right side. Left side NB. NB not N1 they have taken. Let us take same. They have taken N1. Okay na? So here N1 equal to N2 sin 30. You can see N1 equal to N2 sin 30. N2 value we can put up and simplify to get 500 upon root 3 newtons. This is the way we can solve. It is very important part for the solving of equilibrium questions. Okay. Is there any problem in this case of understanding? Just I have taken angle 60 degrees firstly, okay na, but they took 30 degrees with vertical. So according to that component resolving, again I have shown here with the as per the diagram, okay na. Next, determine the tension T4 in the figure. Here it is actually a thread, it is connected like this, okay. Here tension will be in this case how much? T1 with respect to point of contact, and with respect to point of contact T2, and here T3, and here T4. Okay. So you just understand that here it is point mass, here it is point mass. So we don't get any problem, directly we can join these points, okay na, and we can take T4 components directly, right. T4 component in this direction we get T4 cos 60 and horizontal direction T4 sin 60. So T4 cos 60 balances mg, T4 sin 60 balances T3. Okay. So in vertical direction T4 cos 60 balances 10g means 100 Newton. So we have here whatever the force acting in y direction is 0, T4 cos 60 equal to how much? 100. But cos 60 how much here? 1 by 2. So 1 by 2 equal to 100 on multiplying to right side. So it become 200 newtons. This is final answer for the question. So actually by looking at the diagram it will be looks like a clumsy, but it is very easy to solve, okay na, by taking resolving into components, right. So this is the part related to equilibrium and based on that some questions. Thank you.